Hey guys, this is Joe East here with Easter Analytics. Today we're going to talk about cell versus system voltage. Notice that we have a pile of plywood on the right side of the first slide. Well, what does plywood have to do with cell versus system voltage? Well, let's talk about plywood first. All right, let's show you what plywood has to do with voltage. So let's say we have two sizes of plywood. Let's say one pile of plywood is a half-inch sheets and another pile of plywood is a three-quarter-inch sheets. Well, if you want to stack these, sheets of plywood into bundles of say 100 sheets, um, the half-inch sheets would stack up to about 50 inches or 4 feet 2 inches. The three-quarter-inch sheets in a bundle of 100 would stack up to about 75 inches or 6 feet 3 inches. So take a look at the little diagrams with the white background to the right top, and you'll see one is 75 inches high and the other one's 50 inches high. This is a big difference compared to the small differences of the sizes of the plywoods, relatively speaking. So the difference between a half-inch sheet versus a three-quarter-inch sheet, when you stack it up to a bundle of 100, makes a big difference on the stack level. And that's very, very similar to what? Very similar to voltage of a battery system on the cell voltage versus the system voltage. So let's take a look at some cell stuff here. So here is a pack of cells. I think somebody tried to assemble a few of them halfway. The priority is minimum cell voltage and maximum cell voltage. You're going to have to sometimes look for this because sometimes it's not written on the cell itself. If you look at the photograph that I have here in the slide, there is something called nominal voltage that is printed on almost all lithium batteries, and it's for the most part useless. So if there's just nominal voltage there, don't be fooled. It's almost useless. There's an esoteric calculation that uses nominal voltage, but for the most part, nominal voltage is completely useless and meaningless. So remember, look for the priority of maximum cell voltage and minimum cell voltage. So if you look at the bottom right corner, I have a table where I put the parameters of cell voltages and system voltages. So if you have a lithium iron phosphate cell from some manufacturers, you'll see the max voltage of 3.8 volts and the minimum voltage of 2.5 volts. So whenever you stack this up to the system level, you only want to consider the on number one here, the priority under number one here, find the cell series stack up. So this stack up is pretty common, which is 4P416S lithium iron phosphate system. You're only concerned with the series stack up, so the S, so 416S or 416S. So you multiply 416 times the max voltage and the min voltage, and you get the system voltage of max voltage system is 1580.8 volts, and the minimum voltage on the system is 1040 volts. I put the nominal voltage there as a half joke because you're going to run into the nominal voltage just for the sake of having to have it there, because a lot of people just use it, but it's hardly ever useful. But it's here on the table, and I put in the notes that it's irrelevant. Nominal voltage is irrelevant. Principle number two is ignore the parallel stack up. So even though the parallel stack up for this particular system is 4P, you ignore it for the system voltages. Okay, in my example is 4P 416S. Uh, only the 416S matters for system voltage calculations. You see the little diagram in the top right. We're taking the cell and extrapolating it into the system voltages here. So that's how you do it. Again, always ignore nominal voltage because it is completely useless. However, you might have to listed in your spec sheets for completeness, because some people just expect it. Just to emphasize the point, nominal voltage is for amateurs. There's one esoteric calculation that a hardcore battery uh, technical people will use nominal voltage, but for the most part, you don't consider nominal voltage at all, except for some weird esoteric calculation that we rarely discuss. So for the most part, nominal voltage is almost always meaningless. Know your maximum voltage and know your minimum voltage on the cell level, and then extrapolate to the system level. Forget the nominal voltage. So why is cell voltage versus system voltage extremely important? The answer is voltage swing, the difference between the minimum and maximum voltage. That's why it's important. So check out this lithium iron phosphate cell voltage swing. Okay, 3.8 volts minus 2.5 volts is a voltage swing of 1.3 volts. Not much, right? 1.3 volts. Can you even feel that whenever you put your finger on it as far as a difference? 1.3 volts? Probably not, unless you put it on your tongue. However, on the system voltage swing, whenever you have 416 of these cells in series, the voltage swing on the system level is 1580.8 minus 1040, which is a big difference of 540.8 volts. So there you go. Big voltage swing on the system level with just a small voltage swing on the cell level. So 1.3 times 416 equals 540.8 volts. That's your system voltage swing. And this is the difficulty that the engineers will have to deal with in connecting to the inverters and other things. And we have come to the end of the session. I appreciate you listening to this presentation. Please contact me here if you have any questions for me. And be safe out there. Take care. Until next time. Goodbye.